Hello, mic test. Hello, Ruth. Hello, Karen. Hello, Safia. Okay, so I guess the sound is working. Okay. Oh, hi, Jillian and Dawn. Thanks for joining. Okay. Wait, Hi, Noriza. Okay, glad to have you all with us here tonight. Okay, this is Kevin from Heuristics, here to bring you another episode of the unit transfer method. This time round, I'll be talking about the all changing quantities. So, okay, there's a lot to cover, so I guess let's get started. Yeah, hi Dolly, Veron, and Raja. Thanks for joining in. Okay, so a bit about myself. I graduated from NTU with mathematics and economics, degree in mathematics and economics. Then I've been working here as a curriculum specialist since 2011. I guess you all know about me already, so I won't talk so much. Let me briefly introduce about my company first. So about Heuristics, we are today a leading content provider in mathematics teaching methodologies. So so the thing is, we have developed an integrated platform to support the learning needs of our students and for the parents who need them. And now I'll be talking about the unit transfer method for all changing quantities. So I must emphasize, if you've been following me for quite some time, you will understand that my stand is that I do not go for the fastest way to solve a problem. There's a difference between teaching a child the fastest way to solve a particular problem versus teaching him a thinking framework that can solve many other problems. It may not be the fastest, and I do not claim it to be the fastest either. So let's get started. Now, if this is your first time watching this Facebook Live, welcome. But there is some prerequisites that you need to know that I have covered in this video link over here. So this is on units allocation. To give you a brief idea on what it is to convert everything into units. So for parents who are well versed with algebra, you'll be thinking like, Tom has half as many stickers as Mary. Just write T is equal to half of M lor. Then can really what? No, the way primary maths is taught is not like this. Instead, the students are taught to think in whole number units. So when Tom has got half as many stickers as Mary, we want to allocate the units like so. Taking note of the keyword. And then when we draw this out to visually represent it, we see that Tom would have 1 unit, Mary would have 2 units. Then Tom has 50% as many stickers as Mary. We want to change 50% into a fraction first. So this is its definition. And then we simplify it down to the lowest terms. So 2 goes to Mary, 1 goes to Tom. Your keyword here is as many. And then you would have simplified the problem a lot. By doing this, you would be dealing with only a few major topics. So that is the brief idea. Let's get started. Now for the label, before I begin the lesson proper, I need to establish a few conventions first. So when you are asked to draw 40 units, okay, if the model is only 1 unit, it's okay to draw 1 box. If the model asks you to draw 3 units, I guess it's still alright. But what if it becomes a very big number, like 40 units? Then it becomes very troublesome to draw out every single bar. As such, this is what we would do instead. We draw 1 bar and we label it as 40 units. Okay, the next one would be on 40 units plus 4. So we draw the same 40 units and then we extend it out by an actual value of 4. Okay, some students have the misconception that this 40U and 4 is 44. No, that is not the case. Okay, these are in terms of units, this is an actual value. So for 40 units minus 4, now this one will take you a while to get used to. The story is this. Okay, when you have 40 units minus 4, or a certain number minus something, this is what's going on. We draw out the entire bar first, and we say that this entire bar is 40 units. After that, we take away an actual value of 4, leaving us with this shaded region over here. Okay, so I repeat again, you draw out the entire bar first, label it as the first term, and then we are taking away an actual value of 4. Okay, this one will take a while to get used to, but don't worry, you can watch the replay. So of course there are other conventions for this, but this is what I strongly recommend. So a few examples. How do we go about dealing with these types of statements when the students have not formally been taught on how to deal with it? We will use models to work around this. Oh, hi Santana. Thanks for joining. Okay, so 3u plus 8 is equal to 5u plus 2. How do we represent this? Let's just say that I draw out 3 units plus 8 first. Okay. The next statement is 5 units plus 2. Therefore, 5 units needs to be longer than 3 units. When you add 2 more to 5 units, the length of the model will be similar or equal to the one on top. And once we have established this, we can now compare between units with units, numbers with numbers, or rather, we want to look at this gap over here. In terms of units, this would be 5 units minus 3 units to give you 2 units. Okay? And at the same time, if we are to get rid of this 2 on this side, that will leave us with 6. So we can say that 2 units is 6, hence 1 unit must be 6 divided by 2 to give me 3. Okay? So up to here, does everyone understand? The positive statement is the easiest one. All good. Ada and Aiden, long time no see. Alright. So we move on to the negative statements. The first type of negative statement is where one statement is positive and the other statement is negative. Now, as a general rule, you want to start out with the negative statement first. Alright, so we draw out 5 units minus 2 first. The entire bar is 5 units, and we take away an actual value of 2, leaving us with this shaded region here. Okay. Now, the next bar, 3 units plus 6, would just be 3u and 6. The important part to note is that this length of 3 units and 6 must be equal to the shaded region on top. And then we can now compare this gap between 5 units and 3 units. If I were to get rid of the 3 units on the left, that will leave me with 2 units. The next thing to do would be to compare the numbers. Now the important part here is to compare the length. And in this case, it is the sum of 6 and 2. This gives you 8. So we say that 2 units is 8. We can conclude that 1 unit must be 8 divided by 2 to give us 4. Then for the negative statement 2, okay, this would be a bit difficult, but let me explain it properly. Now, when you have 2 negative statements, it doesn't really matter which one you start with. Let's say I start with 3 units minus 2 first. We draw out the bar. The entire bar is 3 units, and we take away 2, leaving us with this shaded region here. Okay. Thereafter, we need to draw out 5 units minus 6. Now 5 units needs to be longer than 3 units. The hard part here where students get confused is where does your 6 stop? Some of them would draw it here. Some of them would draw it here. So which one is it? Okay, Safia, I'll come back to that in a while. Okay, right. So this is the part that is correct. When you take away 6 from 5 units, the remaining region here needs to be equal to the one on top. And once we got that, we can now compare between units with units, numbers with numbers. So over here, if you take 5 units and minus 3 units, you would have 2 units remaining. If you take 6 and get rid of the 2 on the left side, you would have 4. So if 2 units is 4, then we can say that 1 unit is 2. Okay? Okay, Safia, which part do you need the clarification on negative statement 1? Anyway, for those of you who got it today, since today is Valentine's Day, I will not ask you for likes. I'll ask you to give the love sign. So can you please give some love if you understand? Okay. Adding the 6 plus 2. Okay, hi Karina. Okay, if we are to look at this again, between 6 and 2, 6 and 2 are over here. This is the gap that is formed by the 2 units. Okay? I got a PM with the love symbol. Wow, a lot of love symbols some more. Okay. Okay, thanks. Alright. Okay, I see most of you understand. Let's carry on. Now this will be the 4th case on how to identify the before, change and after. For this is the all changing quantities. Let's just discuss what it is real quick. Let's say that Ali has $10 and Ben has $35. Ali spent $3, Ben spent $8. Ali would have $7 remaining. Ben would have $27 remaining. If we are to compare the total before and after, the total before is 10 plus 35 to give you 45. The difference of the total after will be 27 minus 7 to give you 34. Then for the difference, the before difference is 25 and the after difference is 20. And then when we look at the change rule, how do we know that this is an all changing quantities problem? When we look at the change rule, we observe that we have different numbers. Now when you have different numbers, it doesn't matter what the signs are. All the quantities would have changed. Alright, before I move on, let me just address a question from Amy. Why not just transfer the units and numbers to their respective side with the reverse signs? First of all, they are not taught this formally at primary school. For us, we take it for granted because we already know it. But for students, they are not really taught this formally. And that is why we have to use models to bypass this. Okay? Alright, let's move on. Amy, I hope I answered your question. So let's go to the guided example 1 first. This one would be at the primary 4 level. You would, P5 and P6 will also see problems like these quite often. So it's not just a P4 only thing. It will continue on to P5 and P6, and until you understand how to deal with this, the problem will not be resolved. So this is what I'm looking at. Basket A had thrice as many balls as basket B. Jane put 84 balls into basket A and 150 balls into basket B. Now both baskets had an equal number of balls. How many balls were there in basket A at first? Okay, first let's identify what we are given. This was before anything happened. This was the change, and this is the after. Let us draw out the before, change, after table and compare between basket A and B. So we see that A has 3 times as many balls as B. Change this to 3 out of 1. 3 goes to A and 1 goes to B. Keyword here is as many. We allocate the units first. 3 to A, 1 to B. 84 balls put into A, 150 balls put into B. Now both of them had an equal number of balls. So sometimes my students also face a bit of trouble with this at first. But what an equal number means, if you are to draw a comparison model, it means that both of them would have one part each. Okay? So once we have set up the table up to here, when we look at the change row, we see that we have different numbers. And this means that all the quantities would have changed. To deal with problems like this, we have to use a modified version of the unit transfer method. What we do is we allocate units for before, we allocate parts for the after. The reason is that the proportions of the before and after are different, and they need distinct units or parts to distinguish them. So once we have that, we write out the two statements. And then we observe that we want to look at what we want to find first. We are to find the number of balls in basket A at first. That would be 3 units in this table. So to compare something like that, you have to make something the same first. In this case, there is no need to make anything the same because the parts are already the same. So we bracket these up because these are the two models that we want to draw and compare. Let's start with 3u plus 84 first. 3 units and 84 gives us 1 part. At the same time, 1 unit and 150 will give you the same 1 part. Once we have this, we can now compare between units with units, numbers with numbers. So if I were to get rid of the 1 unit here on this left side, that would give me 2 units. Now at the same time, this entire length is 150. If I were to get rid of this 84 here, it will leave me with this gap over here. And that would give me 66. We can say that 2 units is 66. 1 unit must then be 66 divided by 2 to give me 33. And once I got that, the objective of 3 units can be found quite easily. There will be 3 copies of 33, and then I would have 99. The final answer here would be 99. Alright? So up to here, if you understand, do give me some love. Not the like. For today, I'm requesting for the love sign. If you're not sure, please leave your comment here. Then I'll address it if I can. Okay, I see a few love signs. Thank you. 谢谢你的爱。That means thank you for your love in Mandarin. Okay, so I see most of you understand. I think I can continue first. Alright, now we move on to a plus or minus variation. Still at primary 4, but please be reminded that these questions will still appear at P5 and P6. Now, Don and Jack had the same number of cards. This is before anything happened. After Don bought another 48 cards and Jack lost 12 of his cards, Don had 3 times as many cards as Jack. This is the change, and this is your after. How many cards did each of them have at first? Right. Now they have, okay, let's draw the BCA table first between Don and Jack. Right. Now they had the same number of cards, which means this would be 1, this would be 1. Don bought another 48 cards and Jack lost 12 of his cards. Don now has got 3 times as many as Jack. Right. Once we are done up to here, we observe the change rule and we see that we have different numbers. So when we have different numbers, we need to use units for before, parts for after, because the 2 proportions are now different. Then we write out the 2 statements first. 1U plus 48 is equal to 3 parts. That is for Don. And for Jack, that will be 1 unit minus 12 to give you 1 part. Then once we have that, we need to find the number of cards each of them have at first. So that would be 1 unit that we want to find. Correct? And just now I was saying earlier, when you want to find units, you make parts the same. However, you do not have to follow that rule strictly. Sometimes you can exercise your flexibility, and we observe that the units are already the same. When they are the same, we can start to draw out the models and compare them. There is no need for multiplication at this point, but you have to be aware of what you are finding. Alright, so as a rule, start with the negative statement first. Then it will be easier to fit in the positive statement later on. 1 unit minus 12 is 1 part. We draw out the bar, 1 unit, take away the actual value of 12. That leaves us with 1 part. Next, we draw out the same 1 unit and we add 48 to that. This will give us a total of 3 parts. Once I have done this, I do not need to care about my units anymore. I only need to look at my parts. When we compare parts with parts, numbers with numbers, 3 parts ends here and 1 part ends here. Now I want to chop off this 1 part and get rid of it. When I do that, that leaves me with 2 parts. As for the numbers, we can see that the entire length is formed by 12 and 48. We need to sum these 2 up, and this will give us 60. Once we have this, we can say that 1 part must be 60. 2 parts here is 60. So one part here must be 60 divided by 2 to give you 30. And once we have this, we know that this one part is 30. We need to find out the 1 unit over here. We can just work backwards. Take 30 and plus 12, and that will give us 42. Therefore, the final answer here will be 42. Alright, if you understand so far, please give me some love. If you don't understand so far, give me some love, then leave your comment down below. Okay? What happened? Okay. If you find it funny, just give me some love also. 谢谢你的爱。Okay, right, up to here, I guess more or less, judging from the response, I believe you all understand what's going on. Let's go into something more difficult. Now, those two problems, I do admit, they can be solved by models very, very quickly. Yeah, Aisha, 60 is equal to 2 parts. Okay, those two problems, I do agree, they can be solved very quickly. A lot of things are unnecessary, so to speak. But when you come to a problem like this, the model drawing becomes more difficult, more challenging, because the numbers are now not so friendly, so to speak. Right. Those two were just the warm-up for the last two questions. Okay, there are 4 times as many red pens as blue pens in a box. Allocate the units first. 4 goes to red, 1 goes to blue. This is before. 415 pens and 46 blue pens were removed from the box. This is the change. And as a result, the number of blue pens became 3 times as many as the number of red pens. This is the after result. How many blue pens were there in the beginning? Blue pens in the beginning. Now let's draw out the before, change and after table first. Red, blue, B, C, A. Oh, hi boss. Okay. Alright, let's start with the before statement. Red pens got 4, blue pens got 1. Then the red pens and blue pens were removed. Minus 415, minus 46. Now your blue pens got 3, the red pens got 1 part. Okay. Now we look at the change row. We observe that there are different numbers in the change row, which means all the quantities will have changed. Therefore, we need to use units for this before. We need to use parts for the after to distinguish that they are 2 separate proportions. Then once we got that, we write out the 2 statements first. 4u minus 415 is equal to 1 part. And then the next one would be 1 unit minus 46 to give me 3 parts. Okay. Now we are to find the blue pens in the beginning. That would be 1 unit. So as a general rule here, we have to make something the same by multiplying them. Either way, you have to multiply something, so we might as well go for the more direct way. Here's the general rule. To find the units, make P the same. Alright, let's look at these 3 parts and this 1 part. Between 3 and 1, their lowest common multiple is 3. We have to get this 1 part to 3. To do that, we have to multiply this entire statement by 3. So that will become 4 units times 3, 12u, minus 415 times 3 to give you 1245. 1 part times 3 gives you 3 parts. Okay, then once we have done that, we can now draw out these 2 models. Since both of them are negative statements, it doesn't really matter which one you start with. So let's say I start with this. Okay, let me draw it. Let me draw it here. Your whole bar is 1 unit, you take away 46, and now you are left with 3 parts. Next one, you draw out the entire bar, 12 units, take away 1245. That will leave you with the same 3 parts. So once you got that, well, some of you are really quick, Angela and Sharon. Once you got that, you can compare between units with units, numbers with numbers, and then 12u, get rid of that 1 unit on the left, will give you 11 units. That 11 units is made up of 1245 minus 46. Okay. And that will give us 1199. 1 unit will then be 1199 divided by 11. Okay, and that will give us 109. And since this 1 unit is 109, this is precisely what we were required to find. Therefore, the answer here must be 109. Okay, if you got it, give me some love. If you didn't get it, give me the love first, then after that write in the comment. I'll clarify a few later. No, not the thumbs up, the love sign. This one. Okay. Very nice, Angela and Sharon, you all got it. Thanks for taking part. Yeah. Okay, I guess most of you understand, so I'll move on now to number 4. Now this part is a bit different from the standard questions that you saw earlier. Bernard, the notes on the models, you refer to the replay later on. Okay. Last example we added, but here we subtract. Okay. Now you have to look at the situation. It is not always the case that you add or subtract, but it is very situational, very situation dependent. So here, you are getting rid of the 1 unit on the left side. I just want this part here. Okay? Okay, hopefully I clarified that stuff here. Okay, now example 4. This one is a bit different. Okay, Christine has a box of black pens and a box of red pens. There is no information here. The number of black pens is twice the number of red pens. 2 goes to black, 1 goes to red. This was before anything happened. Now this part is a bit tricky. Christine removes 4 black pens and 3 red pens from the boxes each time. Each time, not just once, but each time. So this is the change. After that, a few rounds, there are 18 black pens and 1 black pen, 1 red pen left in the 2 boxes. This is the after. What was the total number of pens that Christine has? Okay, let's draw out the BCA table first. And I need to elaborate on this each time. Alright, for black pens and red pens, this is 2, this is 1. Quite straightforward. Now, for my students who did this question before, the most common misconception is they will just put -4 and -3 here. Okay? Then there would be 18 black pens, 1 red pen left. So these are the actual values. You really got 18 physical pens remaining and 1 physical red pen remaining. Right, let us look at the situation first. For your black and red pens, the black and red will be 2 units and 1 unit in that proportion. Now for this change statement, why is it not just 4 and 3? Imagine this. You take 4 black, 3 red once. You take another 4 black and 3 red the second time. And then you keep on taking until you got 4 black, 3 red. You don't know how many this is, but you do know that you are left with 18 black, 1 red. So let's call this the pith group. Once we have that, we can say that you take out 4 parts of black and you take out 3 parts of red. Because for every 4 black that you have, you are going to take away 3 red. Okay? So once we have established this is the hard part. But once you have established this, everything else becomes quite similar. The procedures become quite similar. So let's draw out let's try out the 2 statements first. 2 units minus 4 parts is equal to 18. The second one will be 1U minus 3 parts is equal to 1. Once we got that, we want to find the total number of pens that Christine had, So that would be the total amount, which is 3 units at first. Like what I was saying earlier, to find units, make parts the same. Alternatively, you can choose to make units the same, but this is the general way that I prefer. Okay, multiply this by 3, multiply this by 4. Why is there a fly here? Okay, so 2U times 3 gives you 6 units. Minus 4 parts times 3, that gives you 12 parts. 18 times 3 gives you 54. The next word statement gets multiplied by 4. 1U times 4 gives you 4 units. Minus 3 parts times 4, that gives you 12 parts. 1 times 4 will give you 4. Once we have done this, we can now draw out the 2 models and compare them. Alright? So let me draw it here. Let's start with 6 units minus 12 is equal to 54. Your whole bar is 6 units. You take away 12 parts, and then you are left with 54 here. The next statement, you have 4 units, you take away 12 and you are 12 parts, and then you are left with 4. Now, as a general rule, you want to put the 12 parts together, which will be on the right side. So we want to start the model from here instead. So we say that this entire bar is 4 units. When we take away 12 parts, we are now left with 4. Once I have this, this is the gap that we want to compare. So since I'm kind of running late on the time already, if we are to chop off 4 units from 6 units, we will be left with 2 units. And then again, if we are to chop off 4, this 4, from this entire 54 here, this would give us 50. So knowing this, one unit will be 25. Because 50 divided by 2 will give you 25. And then the objective is the 3 units. The 3 units will be 3 copies of 25 to give you 75. Alright? I do apologize, there's a lot of content I needed to cover today, so today is a bit overrun. But please give me some love if you've enjoyed this. 谢谢你的爱。Wow, thank you, man. wait. Okay. Yeah, I got it. I got it on screenshot. Okay, got it. Thank you all for this. Thank you for joining. Yeah, Angela, got it. 35 pence. Good. You're welcome, Veron. Okay. So that is the end of the mini course. Next week I'll be doing a revision to sum up all the things that I came. Next week I'll be doing a revision on the 4 different types of BCA and how to identify them. It will be a brief recap. Hopefully it will be in time for the CA, for those who have the CA. And this would be, if you like what you see, this is the unit transfer method online program. It consists of the unit transfer method guidebook, the web teaching videos, somewhat like this, just not in the interactive format, the Maths Heuristics app, the virtual classroom, and the Facebook group. VIP access to our Facebook group. Well, thank you for your love. Okay, let me just type in this real quick. Okay, you're welcome. Colleen, Angela, Vasanti, Safia. Alright, thank you for joining me. So let me just type in this real quick. /6. Oops, forgot to add in one more thing. Right, that is the link to why I cannot pin this? Okay. Sean, Sui, Bernard, Raja, Safia, and Don, thank you for joining me here. Yeah, it's a lonely night tonight at my office. Thank you all for your love. 谢谢你的爱. Okay. Right. Later I'll pin that comment. But anyway, if you have enjoyed this, please, all I ask of you is to like. What happened to my pen? Okay, is to like and share this video. You're welcome, Dolly. The share button is just at the lower left corner of your screen. So please just tap that. Share it on your newsfeed. That will be good enough. That's all I ask for. Okay, thank you for your love. What happened to my stylus? So if there are any questions, I'll take them now. And do remember to spam this one here, just to let Facebook know all of you love me. Okay? Oh yeah, happy Chinese New Year too. By the way, some non-academic related stuff. Tomorrow is Total Defense Day. And so, okay, then let me just share a bit of something that I learned from my reservist. So my reservist is from police force. What they brief us is they are focusing a lot on SG Secure too. So please be safe this holiday. Please look out for one another. So if that is okay, yeah, okay, thank you. Thank you for the happy Chinese New Year thing. Okay, so for those of us who are celebrating Chinese New Year, have a good one. And for those of you who are not celebrating the Chinese New Year, just take this time to have a good break. Alright, so stay safe, have a good holiday, and rest well. It's not academic related, but yeah, I thought that I should let you all know about that. Okay. So I guess if there are no questions here, then I'll sign off now. Thank you for having me. This is Kevin from Heuristics, signing off. See you soon. Stay safe, stay happy.